Hello, lovelies. In today's lesson, we are looking at how oceans impact our weather. So here we have an image of the map, a map of the world, where we see North America and Europe. And if you didn't know this, the weather in Europe is very different from the weather in northern Canada, even though they are at similar latitudes, which means they're similar distance away from the equator. You would think being the same distance away from the equator as another place, you would have the same kind of weather, but they don't. Well, let's dig into why. Convection is the big why. It's the Kickstarter here. And we've learned about convection before. Convection is a transfer of heat energy through liquids or gases. So anything that's fluid, anything that moves. And the reason why convection happens on Earth is because the Earth is tilted and receives radiant energy from the sun or unevenly. The equator gets the most direct sunlight, so it gets the most direct radiant energy, whereas the poles get the most indirect light. And so they get less radiant energy throughout the year. And we've learned so far that that happens in the atmosphere, but it actually happens in the oceans too, because it's a fluid, and convection happens in a fluid. So radiant energy from the sun heats the oceans on Earth, just like it heats the atmosphere, and it heats it unevenly. That means that ocean waters near the equator are warmer because they receive more direct sunlight. Because of convection, those warm currents flow away from the equator. If you look at this image, you can see those red arrows. Ones that are red are moving away from the equator because they are less dense, and so they're rising towards cooler areas. Ocean waters that are farther from the equator are cooler because they receive less direct sunlight or radiant energy. So if you notice that those blue arrows, all the blue arrows are moving back towards the equator because they're more dense, colder waters that are moving back towards warmer areas to replace the warm water that has moved away. And that's because of convection. The temperature of the ocean current influences the air mass above it. So this is tying it back to weather and those climates that we saw in Canada and Europe. The temperature of the ocean current influences the air mass above it. So if the water is warm, then the air above it is also warm. And if the water is cool, then the air above it is also cool. So for example, I see a blue arrow here moving along California. This is called the California current, and this ocean current is moving away from the poles and back towards the equator, which means it's a fairly cold current, which means the air mass above it is fairly cool, and that's why California's climate is so cool all year round. Whereas the Gulf Stream, and it's not shown here in this image, but the Gulf Stream also shows up here in the Gulf of Mexico. The Gulf Stream is warm. It's a red one here, which means it's moving away from the equator and back towards the poles. It's a warm water current, which means the air above it is also warm. And that's why our coastline, or the Gulf Coast, is fairly warm all year, and why the East Coast of the United States has a fairly mild, warm climate throughout the year. It also is why Europe has a fairly mild climate and is warmer than you would expect for something that's at the same latitude as Canada, which is really cold most of the year, with some exceptions. It's not even near a current, so it's only taking in dry air masses that don't affect its temperature or don't regulate its temperature as much. So oceans also have a big influence on storms, on weather systems like hurricanes, typhoons, and cyclones. This is a hurricane-ready sea surface temperature map from August of 2006. And what you're seeing is all of that orange and yellow are sea surface temperatures above 82 degrees. And warm water fuels storms, just like warm water fuels warmer climates. And so in August of 2006, these are all of the areas where the water and the air masses above it were ready to form hurricanes. And if you notice, it's the same locations on this map where it's showing where typical tropical storms form. And sometimes they're called hurricanes, depending on the location. It's called a hurricane, a cyclone, or a typhoon. But it all goes back to the sea surface temperatures and how oceans impact our weather. So those are the basics. There's a whole lot more to this, but those are at least the basics to get you started. Have a great day, guys.